This is Check 3023 Unit Operations. My name is Roel Wright, and today I will be discussing heat exchangers. What is a heat exchanger? Heat exchangers are devices designed to transfer heat between two or more fluids of different temperatures. In simple terms, it's something that transfers heat from one place to another. Depending on the type of heat exchanger employed, the heat transfer process can be gas to gas, liquid to liquid, or liquid to gas, and it can occur through a solid separator which prevents mixing of fluids or direct fluid contact. These are important for facilities because it is mainly used for cooling, so there's no overheating which can lead to combustion. Exchangers. To fully understand heat exchangers, you have to understand the basic laws and principles. The first principle is the zeroth law of thermodynamics. This this is when systems that are in thermal equilibrium have the same temperature. This means if two systems are each in thermal equilibrium with a third system, then two systems must equal each other, resulting in all three systems being the same temperature. For instance, as you can see, since A equals C and also equals B, that must mean B equals C. That is the basic law of that is the zeroth law of thermodynamics. This establishes temperature as a measure property of the thermodynamic systems. Next, we have the first law of thermodynamics, also known as the law of conservation of energy. This simply states that energy cannot be created or destroyed, only transferred to another system or converted to another form. For example, if heat flows into a system from its surroundings, there is an equal increase in the internal energy of the system and an equal decrease in the energy of the surrounding environment. This law describes the inverse relations between a system's internal environment and that of its surrounding environment. Next, we have the second law of thermodynamics. This states that entropy increases over time. As entropy increases in two separate systems, it becomes closer to its maximum value. When this occurs, the system reaches equilibrium. As established by the second law, entropy can only increase, it can never decrease. As the entropy increases, the variable moves towards the highest value achievable for the said system. At this value, the system reaches a state of equilibrium. Therefore, the only system changes possible are the ones in which entropy does not change. Altogether, these three principles dictate the underlying mechanisms and operations of heat exchangers. The zeroth law established temperature as a measurable property. The first law describes the inverse relationship between the system's internal energy and that of its surrounding environment, and the second law expresses the tendency for two interacting systems to move towards thermal equilibrium. Now are the types of heat transfers that can occur in heat exchangers. The design of a heat exchanger is an exercise in thermodynamics, which is a science that deals with heat energy flow, temperature, and relationships to other forms of energy. To fully understand heat exchanger thermodynamics, a good starting point is to learn about the three ways in which heat can be transferred. These three ways are the following: conduction, convection, and radiation. Conduction. This is the passing of thermal energy between materials that are in contact with one another. For example, When a warmer object is in contact with a cooler object, the cooler object will be more energized, and the warmer object will lose energy or heat until thermal equilibrium is achieved. This is represented by this equation. Q over T equals Ka delta T. Q over T is the amount of heat transferred in time. K is the thermal conductivity constant, while A is the cross-sectional area of the material, and delta T is the temperature gradient, which is the warmer object minus the cooler object. Next, we have convection. Convection is a transfer of thermal energy from a surface by motion of a fluid such as air or water that has been heated. This is best represented when it's wintertime and you're turning on the heat. When this happens, warm air rises to the ceiling because it's less dense and transfers heat as it collides with the air initially in the room. This change is called convection. It can be represented by the simple equation Q equals HCA delta T, where Q is the rate of heat transfer, HC is a convective heat transfer coefficient, A is the surface area over the process, and delta T is the change in temperature between the surface and fluid. The final type is radiation. Radiation is when heat transfer that involves emission of electromagnetic waves from a heated surface or object. For example, like warming your hands over a campfire. The fire gives off, electromagnetic waves, which then bounces off your hands, causing your hands to warm up. This equation is represented by Q emissivity coefficient material times the heat radiated from the object multiplied by the temperature of the fire, which is hot in this instance, minus the temperature of your hands or the cold object, and that would equal Q. Now for the different types of heat exchangers. There are several different variants of heat exchangers available. Some of them are more common variants than others, depending on the type of industry, space, and cost you'd like to use. I will discuss 4 of them. They are as follows: the Schelling tube, the double pipe, the plate, and condensers, evaporators, and boilers. First one is Schelling tube. This is constructed of a single tube or series of parallel tubes enclosed within a sealed cylindrical pressure vessel. I'm so sorry. This is designed so that one fluid flows through the smaller tubes and another fluid flows around or between the sealed shell. You can see this as this is the inner shell. The fluid would flow consistently through here and goes out here, while the outer or the tube inlet is this right here. And as they meet at this point, this is when the change in temperature occurs. This type of heat exchanger is common in oil refineries, oil cooling, steam generation, and preheating. Next, we'll talk about double pipe. This is another type of Schelling tube heat exchanger, but this consists of 2 or more concentric cylindrical pipes or tubes. This is when one large tube with one or more tubes within it. One fluid flows through the smaller tube while the other flows around the smaller tube within the larger tube. This is common in the industries that this is common in cooling industries that use cooling processes and small heat transfer area requirements. What basically happens, similar to the Shetland tube, is fluid 1 gets put through a pipe, and between the pipe is fluid 2. And when they meet up, at this point, this is where the heat exchange is occurring. Next, we'll discuss the plate heat exchanger, also referred to as the plate type exchanger. Plate heat exchangers are constructed of several thin corrugated plates bundled together. Each pair of plates create a channel through which one fluid can flow, and the pairs are stacked and attached, such that a second passage is created between pairs through which the other fluid can flow. This is common in industries such as cryogenic, food processing, chemical processing, and furnaces. Here in this image, you can see in the primary medium, heat is flowing through the red, while in the secondary, it is flowing through the blue. At this point, or along the plates, is where the heat transference is occurring. It goes from hot to cold to warm to colder, and it just goes down as it cools as it goes down and heats as it goes up. Lastly, we have condensers, evaporators, and boilers. Boilers, condensers, and evaporators are heat exchangers which employ a two-phase heat transfer mechanism. In two-phase heat changers, one or more fluids undergo a phase change during the heat transfer process, either changing from a liquid to a gas or a gas to a liquid. In condensers, heat exchanging devices take heated gas or vapor and cool it to the point of condensation. This is found in common industries such as power plants, refrigeration, and HVAC. Whereas in evaporators and boilers, the heat transfer process changes the fluids from liquid to gas or vapor form. This is common in this is commonly found in industries like steam train systems, and distillation and refinement processes. And that's it for this presentation.